So I got something new for this project. I was kind of excited about it, so I thought I'd tell you guys. You know, there seems to be this gap in drill bits. You have your super high-end, really expensive drill bits, and then you have your cheap Chinese garbage drill bits, right? And then that middle ground for like home shop guys or hobbyist machinists and stuff like that, there's not a ton of choices. The ones that you've seen on my channel up until this point are precision twist. You know, those have been pretty good. That was one of the choices I had in that category. I was scrolling through Facebook or Instagram or something, and I saw one of these ads, and I'm sure you guys have seen him. It's of that guy, and he's drilling through like a brand new file. There's even one where he's drilling through a high-speed steel drill bit, and my curiosity got the best of me, and I called him. I just wanted to know what those drill bits were made out of, you know, if it was real. You know, when you see that stuff on Facebook and you think it's probably fake or something. So I just called him, asked him some questions, and it turns out, so those ones that you see in those demonstrations, those are like masonry bits, kind of. I'm sure you guys have heard that trick where guys will sharpen the small carbide tips on a masonry bit in a pinch to get out something that's hard. Like you break off a tap or something, you can sharpen the ends of a masonry bit. They have their own proprietary blend. It's carbide and boron and stuff like that. Now that didn't get me particularly excited. I'm guessing they probably drill an oversized hole, and they're like, you know, what I would call rainy day bits. They could get you out of a pinch, but you're not going to use them every day. But I got to talking to the guy, and I asked him, well, do you have any regular bits, like high-speed steel bits or cobalt bits? And he did. So this is the high-speed steel index that I got, and these are cobalt. And I've been using both of these on this project, but I actually really like these. They have the ground shank, which is nice if you have it in a drill or something. They have the secondary grind back here, which I also really like. It kind of seems to wander a little bit less than a regular drill bit. I was kind of missing the fact that I didn't have a bunch of tap drill sizes that I needed. So I called them and asked them about this index, and this is your typical like 115 piece index. It goes from 0.040 up to 1/2 inch, and then you have all your letter bits also. But here's the kicker. Every single one of these drill bits has a lifetime warranty on it. If you break these and you send them back into him, he will send you replacement bits for every single one of these, from the very small ones all the way up to the big ones. That was pretty much all I needed to hear. I mean, the price for these was pretty close to the same as what I paid for Precision Twist, and I actually like these better, and they have the lifetime warranty. If you guys are looking for drill bits, I think they're worth checking out. So this is the motor and the pump that I decided to use. This is a 5 horsepower 3-phase motor, and it's VFD rated. It can be run with an inverter, which we'll get to later. And this is my pump. This is a 2-stage pump. We'll also talk about that a little bit later and why I picked this one. But the idea for these hydraulic systems to work is use the motor shaft to spin the shaft on the pump, it sucks fluid in here and pumps it out this end. And basically this is the heart of the hydraulic system. The relationship that you have between your pump and your motor determines what your hydraulic system can put out or what it can run or run efficiently. Also determines the life of your pump and the life of your motor. So the reason this two-stage is beneficial, let's just say you're moving your cylinder, you're actuating the arm to get it in or out of position, like on a press or on a log splitter. It will move a lot faster before it has pressure on it. So if you're just trying to open the log splitter up to get a log in there, it's gonna move, you know, 3 times as fast as when there's over 500 PSI in the system. That's what a two-stage pump is, and that's why I decided to use it. We need something to connect these two shafts, and that's what this is for. This is called a Lovejoy coupler. Lovejoy is actually a brand, but I've noticed everybody calls them Lovejoy couplers, no matter who makes it. This is to fit the motor shaft. This is 1 1/8, and this side is a 1/2 inch, and it's keyed with a set screw. This is obviously not gonna work. There's nothing supporting the pump. So that's why I made the motor to pump coupler. So I know there's some people that are just dying to tell me that you can buy these. And I'm aware that you can buy these motor to pump couplers. This is a, you know, a fairly standardized mount. There's several different types. Based on your motor, determines what type of hole pattern you need for your bolt pattern. And the same thing goes for the pump. It's kind of a standardized system, but there's several different types. So what I did was I made this adapter plate. So this bolts onto the coupler, and if I ever want to switch a pump with a different hole pattern, all I need to do is remake this one plate. Let's talk a little bit about making symmetric, repeatable bends on the Hausfeld bender, or really any bender. I think all of this would still apply. So the first thing that you want to do is make your mark. This line will line up with something on your bender that is constant, like whether it's the edge of a die or something on the bender where it doesn't move. It doesn't really matter as long as that distance is always the same, and every time you make a line, you line that line up with the one on the bender. And I'll show you on my bender where that is, but it could be different depending on what you're doing. So anyway, you want to make a test bend, and this is 90 degrees. After I bend it from my known line, I want to line up a square and measure the distance from the edge to the square, and that's 7 7/8. So I know that each one of these bends takes up 7 7/8 inches of square tubing. So if we know that, and I bring my straight piece over here, we know that I'm trying to get my opening here, I want to be 18 11/16, right? And it's a horseshoe, it's like a symmetrical U. So the first thing you want to do is find your center. So this is 70 1/4 inches long, so 35 1/8. is my center. Now, I know that I want my opening to be 18 and 11/16, and I know that my bends are going to take up 7 7/8 on each side. Take 18 and 11/16 and subtract the bend on both sides. 18 11/16 minus 7 7/8 minus 7 7/8. So then I have that number, and now I'm making two bends that are symmetrical, so I want to take that number and divide it by 2 and then pull that dimension from the center line in each direction. And then that line is going to be my new lineup mark with the bender, and that's where I start my bend. Okay, so in this particular setup, this is the die, and this is like I forget what they call this, it's like a stop block. But the edge of this block is what I use as my lineup mark in this particular situation, because when you apply pressure to the arm here, what it's going to do is pinch the tubing, and the material doesn't move from right there. You pull the square tubing around the die, but the pressure, it's kind of like like a finger trap. The harder you pull, the tighter this pinches on here, and this does not move. So you know that all the material is going to bend after that line. Okay, so now you can see on this side, remember the tubing is pinched over here, it can't move, and then you swing this arm and it pulls the tubing around this die. And this piece right here is a roller, and this rolls, and that way it kind of follows the bend around. Basically these shims here, this just gets the center height of the tubing to the center of this crown. This die is crowned a little bit because when you bend this tubing, the inside of the bend needs to shrink and the outside needs to stretch. So on the inside where you're shrinking, the material needs somewhere to go. So this little crown here forces the material into the square tubing instead of, making wrinkles or whatever. This helps to prevent that.